First question I'm going to address here is, how does packaging design directly affect safety costs and efficiency in the EV battery supply chains? So when I think of packaging within the electric vehicle space, I guess the best place to start is electric vehicles are powered by lithium batteries. I think we all understand that these are extremely large, extremely high-powered lithium-ion batteries. So if we're going to be transporting our lithium batteries, it's important to kind of think about the different ways you would transport an electric vehicle battery. So at least for now, I think I would focus on three areas. The first one would be new packs. So these are brand new packs that are being transported to be integrated into the vehicle. We would also think about used packs being shipped off for recycling. And then in the rare cases, we would also think about packs that have been damaged. And this damage can be the result of a crash, would be an obvious example, but it could also be a result of a known defect within the system, the state of health not showing that the battery is safe for use, safe for transport. It could also be something as simple as an impact during transport. And, think of a forklift impact is unfortunately pretty common. So if you're looking at packaging, it's important to think about which stream you're focused on. You have new batteries, you have used batteries going for recycling, and then you have damaged defective. So if I have a new battery pack, the thing to think about and always keep in mind with electric vehicles is by far the most valuable part of any EV is the battery pack. I've seen some estimates say that it makes up 40 to 60% of the price of the vehicle on its own is just the cost of the huge lithium-ion battery inside of it. So if you're looking at packaging requirements, the DOT, Department of Transportation, for those unfamiliar, is going to regulate how you transport lithium batteries, including large packs like those that power EVs. So if you're looking at DOT regulations for new packs, they're going to give you a pretty wide latitude when you're shipping these things by ground or ocean. So they're going to authorize packaging that is strong outer packaging, protective enclosure. Because these packs weigh over 12 kilograms and usually have an impact-resistant outer casing, they don't necessarily have to be put into a UN-rated package, which, for those that don't run in this world, a UN-rated package is one that has survived a drop test, a stack test, a vibration test, and it's generally thought of as far more robust and oftentimes far more expensive. So when you look at the new packs, there's not necessarily a requirement to have them in top-of-the-line packaging. You can put them in any wood crate, outer box, or even just strapped directly to a pallet. Those would all be authorized for ground and ocean transport. But looping back to what I had said previously, the most valuable part of your vehicle is the battery pack. While you can ship your EV battery in some type of cardboard box or even just strapped to a pallet, question becomes, with something so valuable, is that the best way to protect the asset? So if you're looking at packaging design, oftentimes what you see for the new packs is some more enhanced packaging in terms of sometimes metal outer shells, inner packaging that has foam and certain components in there to prevent the batteries from shifting significantly, because it's really important that the new battery, gets to the assembly point in a condition that is pristine before it's integrated into the vehicle. So from the new pack design, oftentimes you'll see a wide range, but increasingly more some of the more robust packaging to protect the asset. The flip side, though, is when you're looking at recycling. So if you have a battery that is being taken out of an electric vehicle that is going off for scrap or for disposal, oftentimes you'll see those packs being shipped in wood crates, in metal racks strapped to pallets. And on that side of it, if you're looking just at the value proposition, oftentimes people are taking their batteries and they're shipping for disposal, so they don't have as much value as a new pack might. So from the regulatory side, similar concept in terms of UN spec packaging is not required for batteries going for disposal, and any sort of protective enclosure or even strapped to pallets is acceptable. And again, going back from the value proposition, does it make sense to have extremely high-end packaging for batteries that are going off for disposal? Not necessarily. However, with that said, it's not impossible that in the coming years, the regulators will enhance packaging requirements for batteries going for recycling and disposal, because if you just kind of think from common sense, oftentimes those batteries are at higher risk because they've been used, they've been charged and discharged a number of times, so they could be at a higher risk of thermal runaway. The last category is damaged defective. So these are batteries that have known defects or have sustained some type of damage that would make them more likely to undergo a thermal event in transport. This one's a little clearer. Here you don't have a lot of flexibility when it comes to the actual requirements. Here, you're going to be limited to packaging that is either a wood, metal, or plastic drum or box. So this is more tightly controlled, and so you need to have non-combustible inner packaging. It needs to go in, a UN-rated wood, plastic, or metal box or drum. So it's a little bit more tightly controlled in terms of what packaging you're even allowed to use. And as you can probably understand, having some thermal protection, some thermal performance materials involved is certainly going to be required because these batteries are more likely to have some type of fire in transport. So second question we're going to get into here is, what failure modes and risks are unique to transporting large format EV batteries? So if we're transporting EV batteries, there's some important kind of risks involved that are not necessarily going to come about when you're transporting small batteries like the ones in your laptop or your cell phone. So let's start off with new batteries. So what types of risks or what types of things would be unique to transport EV batteries? Well, the first thing you would think about is the size, just the sheer size of these things. So if you look at your average electric vehicle, that's not true for all of them, but for a lot of them, the battery pack makes up pretty much the entire bottom of the vehicle. So it's the entire chassis of the vehicle is just thousands and thousands of cells electrically connected together, built into packs. Those packs are connected through modules. The modules are connected to make up the one single EV pack. So it's an enormous, enormous battery pack. So not only from the dimensions is it large, but it weighs a lot. The size on these things, of course, vary, but you're not going to be surprised to see anywhere from 300 to over 1,000 kilograms is how much these batteries weigh. So if you're looking to transport something that is enormous in dimension and weight, you can probably understand where some of those risks come from. So one of the big risks that you'll see is just sheer movement of these things. Oftentimes they're going to require some type of forklift, sometimes like manual lift. Sometimes you'll see, they have top lift capabilities where you strap them to a chain and you just kind of like a crane where you would winch it up into the air to get it onto the truck. So there's a whole bunch of different ways to move them, but anytime you're working with something that size, there's always the risk that it is going to drop from any significant height, that it can sway back and forth to hit some type of hard surface that could cause damage to the outer casing and therefore possibly cause damage to the internal cells. So the difficulty when transporting the new packs would just be around the sheer size of them. So if you are going back to, what we were discussing on packaging design, if you're not packaging your batteries, if you're just strapping them to a pallet, well, anytime that they're going to be dropped, anytime that they may, run into something else or be hit with a forklift, for example, there's no outer packaging protecting this asset. So if you are transporting them on the other side of it, where you're using some type of robust packaging, maybe a metal outer shell, well, this is a thing where if you do have your forklift going to pick up the battery to load it onto the truck, if the forks are a little too high and hit the metal outer casing instead of the battery, that's a huge win, because forklifts running into your unprotected lithium battery packs, I'm not saying it's true every time, but a lot of the time, depending on the impact force, you might have to call that battery damaged defective and ship it out for recycling, which now you're wasting a lot of money. So from the risk profile of it, the main concern that I would have would be around just sheer size and dimension. Of course, there's other risks in terms of energy. I use the example of your laptop and your cell phone batteries. Your cell phone battery might be 18 watt hours, while your EV pack might be 100,000 watt hours. So just the sheer amount of energy involved can make things a little bit higher risk. When batteries do go to thermal runaway, oftentimes the more energy in the pack is going to make the reaction and the resulting fire much worse. With that said, I'll just tell you from some of my experience that in some cases I'd rather be near a EV lithium pack when it goes to thermal runaway than some power tool packs. And the reason that is the case is, again, going back to just the value of these batteries. If you're looking at an electric vehicle pack, they are oftentimes very, very state-of-the-art in terms of design, in terms of propagation prevention, in terms of battery management systems that balance out cell capacities to prevent imbalances which could lead to thermal runaway. So while yes, they have a lot of energy inside of them, oftentimes the safety features on EV batteries far exceed some of the safety features that you'll see on a laptop or a cell phone. And then the other side of it is just on pack construction. So we think of an electric vehicle pack, we think of it as, it's going to be installed into a vehicle, it's going to go over the road, it's going to hit bumps and vibrations, and it's going to be exposed to temperature increases, temperature decreases. So oftentimes these packs are built in a very robust manner to prevent those types of risks in transport. So that's from the new side. From the damage defective side, that one's a little bit more obvious. If you have a battery that has sustained damage, basically by definition, that means it's more likely to have a thermal runaway during transport or during storage, and those risks are obvious. All right, so protecting against those risks is mandatory. It is something that you need to have non-combustible inner packagings and non-combustible filler materials, and then you are restricted to certain types of UN packaging for those battery packs in a way that you would not be for new packs. All right, so question 3 is getting toward how do EV manufacturers, how can they use packaging to optimize both storage and transport to make sure they're minimizing risk and, increasing shipping efficiency. We've talked a little bit about packaging design and how it will protect the battery during transport. So if you look at the new packs, the DOT regulations, the minimum requirements you need to meet to ship batteries by ground and ocean here in the United States, DOT regulations are going to give you wide latitude in what types of packaging you can use. We've talked previously about the exceptions that would allow for a battery just to be strapped to a pallet. You can put it in any sort of wood box or fiberboard box if you wanted to. So there's not necessarily a requirement to use robust, fire resistant type packaging. So that's from the regulatory side, sort of those minimum standards. But there's a huge piece of the puzzle that gets missed when it comes to transport of lithium batteries. Oftentimes I'm guilty of it myself, being somebody that used to work for the DOT. Oftentimes we kind of live in that bubble of Department of Transportation regulations. The other aspect of this thing is once it's out of transport, it's going to be sitting somewhere. So we're seeing storage regulations that are being developed to not mirror the transport regulations necessarily, but to at least mitigate the risks of lithium batteries in storage in the same way the DOT regulations mitigate the risks of lithium batteries in transport. And this is primarily done around the world through the International Fire Code. Sometimes places are adopting the NFPA standards. The way to look at this is going back to our new packs. If I choose as a manufacturer to ship my new packs just strapped to a pallet, well, that pallet is not providing any sort of fire resistance capabilities. It's just a naked battery and 4 straps sitting on a pallet. So from a storage perspective, under these new fire codes and under these new NFPA standards, that type of configuration is not really helping us. So we don't really have time today to go through all the International Fire Code, kind of the specific ins and outs of what is required and what is not. But best way to think about it is if you are not protecting your batteries in some type of fire resistant container or some type of fire resistant room, oftentimes you're going to need to have additional requirements for how you store those batteries. And the storage side is tricky because it comes down to your local fire department in terms of what they're comfortable with and what they're not. So the challenge that we have with the storage side is that the actual requirements that apply to your facility are driven and dictated by the local fire departments. So it's not necessarily a federalized standard in the same way the Department of Transportation rules are. So from our experience, what we've noticed, of course, is fire departments around the country are a lot more comfortable with on-site storage of EV packs if those EV packs are stored in some type of fire-resistant container. This makes sense, right? So if you have a lithium battery or an EV pack that goes to thermal runaway, if it's just strapped to a pallet, there's nothing that's going to mitigate the fire produced from that thermal runaway event. And that fire then can spread to the pack next to it, which could spread to the pack next to it, which could spread to the pack next to it, and suddenly, unfortunately, you have a catastrophic fire that is risking people's lives. And unfortunately, we've often seen, entire buildings burn down, major property losses, and that is all due to propagation of one battery to the next. So if you think about an alternative that not only meets transport regulations, but also gives you storage advantages, would be some type of fire-resistant container where in the unlikely, but it happens, event that you have a thermal event of a lithium battery, if it's inside of some type of fire-resistant packaging, yes, you may still have that battery go to thermal runaway, but the fire and the smoke and the projectile from that battery will not be passed on to the next battery, causing the next battery to go to thermal runaway and having that catastrophic event. So from transport side, there is a lot of leeway in terms of packaging, but we always talk to our clients about not only for transport, because once transport ends, it's going to be stored somewhere. And so how does your packaging design help you on the storage side as well? And this is something that's not just nice to have, it's not just theoretical. This is something that we've seen major manufacturers adopt more fire-resistant packaging to get out of having to retrofit their buildings, or in some cases to just even allow them to store lithium batteries at their facilities, because increasingly and understandably, we're seeing fire chiefs around the country that are a little bit nervous about having tons and tons of lithium batteries stored within their jurisdiction. So if you have some type of packaging design that mitigates those hazards, oftentimes it's going to make those fire departments a lot more comfortable with what you're doing.